Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be looking at 5.3b, dividing radicals with conjugates. So the definition of a conjugate is essentially where you're forcing something to be a perfect square. So the conjugate of our denominator here would be -3 minus the root of 3. The only difference between, so conjugate comes from a binomial, the difference is the sign in the middle. And so in order to simplify this or divide this and get the radical out of the denominator, we need to multiply our bottom by the conjugate and multiply our numerator by our conjugate as well. So using our radical multiplication, so distribute, I'm going to have -3 root of 5 minus root of 15 over, I'm just going to show the long way for the first example, and then it's going to have a pattern that we can use to simplify and speed up our process. So we're going to do our first. So -3 times -3 is 9. Outside, we're going to have +3 root of 3. Inside, -3 root of 3. And our last, which is going to be negative root of 9. So now if we're simplifying our denominator, we would get just write our numerator, -3 root of 5 minus root of 15, can't simplify that. In our denominator, notice our middle terms go away, and we are just left with 9 minus root of 9, which is 3. And I want you to notice how 9 relates to this number and how 3 relates to that number. Again, there's a pattern. So to simplify, our final answer is going to be -3 root of 5 minus root of 15 all over 6. Things you want to do is you want to check to see if you can reduce it all. So you're going to check all your coefficients, and if your coefficients have a common factor in every single spot, you can reduce. In this case, there's a 1 out front here. That means I can't reduce. So this would be my final answer. In our next example, so again, in order to get rid of that radical out of our denominator, we're going to multiply by the conjugate. So again, the conjugate is the same as the bottom, just the opposite sign in the middle. So times 5 minus 5 root of 3. So if we distribute, I'm going to have 10 minus 10 root of 3 over, so first, outside, inside, last, so minus 25 root of 9. Again, notice middle terms are going to cancel out. That's going to happen every time because we're forcing it to have a difference of squares look. So numerator, 10 minus 10 root of 3, we can't add those because there's no like radicals, and we've got 25 minus 25 times 3. So 10 minus 10 root of 3 over 25 minus 75. 10 minus 10 root of 3 over -50. And this one, when we check all of our coefficients, we do have a common factor. So if we divide each of those by 10, our final answer is going to look like 1 minus root of 3. Really, there's an invisible coefficient of 1 in front of that. Over 5. Ooh, -5. And one other thing, so while this wouldn't technically be wrong, we kind of want to transfer either the negative out front or divide everything by the negative as well. So what our final answer and the proper answer should be would be -1 plus root of 3 over 5. That is the proper look for our answer. Oh, there's not a ton of room for this one. That's okay. So same thing. Going to multiply by my conjugate, which is -2 plus the root of 5n squared. Only difference is the sign. -2 plus the root of 5n squared. So if we distribute in our numerator, I'm going to have -6n plus 3n, plus 3n root of 5n squared. All over. So again, when we forced a perfect square, a difference of squares, the difference of squares comes from the square of the first term, so 4, minus the square of the last term. And a square root squared is always whatever's underneath it. So 5n squared. I'm going to work sideways, which you should never do, but I'm going to do just because I have no room left. All right, so if I simplify, I'm going to have a negative 6n plus 3n. Oops. I'm actually going to take out my square root of n here, so I'm going to take out one n, 3n squared root of 5 all over 4 minus 5n squared. There's our final answer. There's no common terms between every single term. So in this one, we would have to look at every single coefficient, and there's no common factor. Next one again, so negative 1 minus the root of 5, and we're going to multiply the numerator by the same thing. So distribute 1 first, outside, plus root of 5, inside, plus root of 3, and last, plus root of 15, over, again, our difference of squares is always going to be the first term squared minus second term squared. So this would be 5. Simplify wherever we can. In our numerator, we can't at all because there's no like radicals. All over negative 4, and then we just want to distribute or divide that negative through. So negative 1 minus root of 5 minus root of 3 minus root of 15 all over 4. And 1, I believe this is our last example. So to start off with, notice in our coefficients, every single term has a common factor of 2. So in order to simplify our numbers, I would divide every single coefficient by 2. So I'm going to end up with root of 5 plus root of 2 over 1 plus 2 root of 2. In this case, my conjugate is going to be 1 minus 2 root of 2. So when I multiply, root of 5 times 1 is root of 5. So first, outside, minus 2 root 10, inside, plus root of 2, and last, minus 2. Root of 2 times root of 2 is root of 4, which is 2. All over, so first term squared, which is 1, minus second term squared. So coefficients times coefficients times oh my gosh, I can't talk. 2 root of 2 times 2 root of 2, coefficients with coefficients, radicals with radicals. So that would give us root of 4, which is 2. So now if I come up here and work, simplify wherever possible, root of 5 minus 2 root of 10 plus root of 2 minus 4. There's no like radicals, so I can't combine. Over 1 minus 8 is negative 7, and just divide the negative through. So negative root of 5 plus 2 root of 10 minus root of 2 plus 4 all over 7. That is our final answer.